This is page 3 of the Curve Sketching FRQ worksheet. So the figure below shows the graph of g prime. So we're looking at the derivative function graph with domain from -3 to 4. Determine the values of z for which g has a relative min and a relative max. Just fair answer. So if we're looking at the derivative graph, we need to be aware of a couple of things. Is that the y value, or the y-axis, no longer represents the physical location as it did with the original function. Now the y-axis represents the slope of the original function. So we have to interpret things a little bit differently when we're looking at the f prime graph. So what that means, first off, is that any of the points that you see above the x-axis represents where the original graph has a positive slope. Okay? Any points that lie below the graph represents where the original graph has negative slope. Okay? So anything above the x-axis represents positive slope for the original graph. Anything below the x-axis represents negative slope for the original graph. Now, any points that lie on the x-axis represents where the slope of the original graph is 0. Okay, so then from there we should be able to create a sign line. I like to create a sign line so that I can have a better visual as to what the original graph resembles or looks like. So that means our critical points will be at, I'll estimate that as -2.5, at 0, at 2, and then at 4, and I'm also going to include -3 because -3 is an endpoint. So from here I have my critical points at -2.5, 0, and 2. I see that between -3 and -2.5, the entire portion of this graph sits below the x-axis. So we know the original graph is going to will have a slope, have a negative slope in that interval. So I'm going to represent that with a negative as well as an arrow that points down. Okay. Between -2.5 and 0, notice that the entire f prime graph sits above the x-axis, so that represents where the original graph has a positive slope. So I'll represent that with an arrow that goes up. Between 0 and 2, we see the graph sits below the x-axis, so that represents where the original graph has a negative slope. And then between 2 and 4, the graph is above the x-axis, so positive slope. Now this sign line is a much better picture in terms of helping us to visualize what the original graph looks like. So the original graph is going to decrease, hits a relative min at -2.5, increase, hits a relative max at 0, decrease, hits a relative min at 2, and then increase again. So then for part A, we can say the graph has a relative min and relative max in these intervals here. So relative min in the first and third interval, relative max, relative min at -2.5 and at 2, and then relative max is at 0. Okay, and we have to also indicate justification here. So relative min at -2.5 and at 2, simply because f prime changes from a negative to positive. Same here at 2, from negative slope to positive slope. Relative max is at 0 because f prime changes from positive to negative. All right, part B, we're looking to determine when the graph is concave up and concave down. So now if we're looking at the f prime graph, we can identify where the points of inflection is, as well as where the graph is concave up, concave down, by looking at the behavior here. So any peaks and valleys for the f prime graph represents points of inflection. So these are points of inflection because this is going to be the point where the slope of the original graph is going to reach its steepest point. Okay, so here it's going to reach its maximum steepness before it starts to level off and where the slope will become more gradual. And then here again, the slope will reach its minimum steepness, or the steepest a point in the negative direction before the graph starts leveling off again. And then again, at 3, there's going to be a maximum steepness arrive. So the maximum steepness of the curve is, another word for that is point of inflection. And then where the slope is positive for the f prime graph represents where the slope is becoming more positive. So whenever the graph is becoming more positive, whenever the slope of the curve is becoming more positive, that indicates where the original graph is concave up. So we know that in this interval, concave up, point of inflection at -1, decreases here, so concave down, hits point of inflection, concave up again, and then hits another point of inflection, and then concave down. So we can put all that information onto a sign line here. So looks like points of inflection is at -1, 1, and 3. And then we can identify concave up just by looking at the symbols here. So concave up from -3 to 1, concave up from 1 to 3, because f double prime is positive. Concave down is from -1 to 1, and then from 3 to 4, because f double prime is negative. Okay, now if we put all this information onto the same sign line, we can get a much better picture as to how the original graph is going to look and the behavior of its slope as well as its concavity. So we're expecting a relative min at -2.5. We expect a relative max at 0, a relative min at 2. So I just went ahead and I just plotted those points here. Those will be the peaks and valleys of the graph. And then at -1, 1, and 3, those will be where the concavity changes from concave up to concave down, or vice versa. So then once I plotted those points, I can just connect the graph here. So concave up hits a relative min, remains concave up until it hits a point of inflection, and then becomes concave down, hits a point of inflection, concave up, decreasing, hits a relative min, increases, concave up, hits a point of inflection, and then concave down again.